Hello there, and welcome back to another day where you have some free time. And in this day's video of unstd-c, we'll be trying to debug our own implementation of malloc and free. So let us get started by, well, I've already done the rebuild. So let's try rerunning our executable via GDB. So break at free. Oh, gotta run that first. And then let's see. Well, surprisingly, we now have a segfault because on our last video, here in free, I changed the zip data to a double pointer. Gotta change that back. And here as well. So what should I do? Well, I got the pause here for now. And I'll be back when I have cleaned this up. Okay, now that I've cleaned this back up, I actually need to quit in GDB and rebuild this and actually do this one more time. So break out free, run it, no debug info since that will download the stuff from glibc. So let's print out the pointer. And if we treat this as a structure of heap chunk type, oops, and subtract 1 to it, we got the first one for A, and we can print its size to be 8, the one that we've allocated to it. So that is fine. So what will be the size of our libc memory now? Oops. It's 4031. And now it's 4063. So that is fine. But what now for when we free letter B? So let's see. Let's print out C. So I guess this is the new one. And when we free this thing, I guess the one that I feared from the previous video actually came true. So I did this one wrong. So this is how I've made an infinite loop. So libc memory contains free. Then we took A from that free section and B. When we freed A, well, libc memory will now have B, then B points to free, and the free section now points back to A, and A points back to B. So we have an infinite loop over there. And I guess it's the way I add it back to the free section. So I guess it's time I add the, what do you call this? The previous size section on the heap data. itself. So size t, prev size, so that well, it would actually not do that. So in our malloc implementation, we can remove the next and previous stuff, pointer arithmetic over here, and we just need to make the new free pointer point to that. But in here, the new freed pointer will be I guess we gotta change the previous size. Wait a second. Where is this getting it? Oh, it's in the heap data. This should be in the heap chunk. My bad. So previous size, and that shall be the size of, I guess, this one, this current one. So C size. And since we're not using the linked list portion of the heap chunk type, we can remove that. And here in free, well, no, I guess we're still using the linked list portion here, but it's just the next one. So for this part over here, well, this can remain the same. But for the new free pointer, I guess I actually do need to add a trimming and coalescing function for combining back the free pointers and splitting them when needed. So I guess that will be our new path. But it's almost 10 minutes already. And I've already gone past that on the last episode. So I guess let's just rebuild this for now. And let's see if there's actually an unmap that would happen. And there is still none. So I guess we're subtracting more to the size when we do a when we do a malloc over here. But I am not seeing much of a difference when we actually free this thing. Since, well, it's subtracting the size of this one anyways. Or maybe, well, instead of the next one, I can just make this F and add that here. And just put this inside parentheses just in case. Rebuild it, then use GDB on that, and add a breakpoint on free. run it, and see that our letter F is a heap chunk. And what is the size? Okay, now that is a problem. So, if we print out our pointer over here, it's 7040, and libc memory is 7000. Then we got to treat this as a character pointer later on. And we add the size of the heap chunk type. It is 7040, the same size as this. But if it's now a void pointer, well, we treat it now as a heap chunk type. Well, I guess it's now pointing to libc memory. And didn't we set the size of this one later on? Yes, we did. So what is wrong with that part? I don't really know. So I guess subtracting 1 in here is the wrong move, maybe? Since this address is very much different to what we have. And this time, we're freeing A. So, hmm, what have I done? Since over here, it seems to have increased instead of subtracting it. So, let's try to add this in parentheses for now before we subtract 1. And then what else do I need to do? So quit that, rebuild, and actually rerun this via GDB. Breakout free. And then run it. So F over here is now, well, I would like to believe it's now correct. Oops, gotta print this out. Okay. And then what else happens? We're now freeing B and see that the size is now 4096. And let's try rerunning this in strace. Well, I'm seeing that there's still no M unmap over here. And it's already 14 minutes. So yes, we did make it back to 4096 here at free. So we gotta change the logic a bit. So in the original size, I add the size of the heap chunk data itself. No, the heap data itself to it. And I should also unmap this with the original size. But I do wonder, why is this not right, you see? So once more, gotta go back to GDB and break out free, run it. Then gotta check at the last one. Oops. So let's check the size and the original size. And what if we print out the size of D? It's 40. Whoa. Whoa, whoa, whoa. It's very much different in here. So, yes, this should be dereferenced twice, as D is a double pointer. So that's where I got it wrong. With now, and then, I believe we're getting closer to the truth. Then we run strace. Now we see M unmap. And I would like to believe that's a good way to end this part of debugging malloc and free. And we need to add the logic for the freed blocks and the other stuff like that, trimming and combining the blocks back together. So thank you for sticking with me this far, and may I see you on the next one.